Good afternoon, everybody. Hope everybody's enjoying IMTS 2016. I am Tim Shimbar. I'm the VP for Technology at AMT, the Association for Manufacturing Technology, and also have the privilege of being the director of the Mtconnect Institute. So we got a special presentation here in a few minutes, and it's around Mtconnect. So for those who don't know, Mtconnect's an open, free data communication standard. It's the dictionary, the semantic dictionary that takes sensor data and device data, puts it in a common format, and allows other people to use that to build applications. So all the great software apps and the developers out there, this is that first domino that must fall before you can get commonality for the rest of your application development needs. At the Mtconnect Institute, we do some serious work with universities and are trying to have deeper engagement with our academic partners. The very first Mtconnect Challenge was held a few years back, and we actually ended up with a student from Clemson University who won the challenge over some of the industrial submissions, which is pretty interesting. And it also keyed up, well, what do you do for further student engagement? And we had our friends at DoD OSD Mantech, Office of Secretary of Defense Mantech, and our folks at U.S. Army Benet Labs, the National Center for Defense Manufacturing and Machining, NCDMM, of course, Mtconnect Institute and AMT all kind of got together and said, what if we focused the challenge just on students? What would happen then? So we decided we were going to roll out a second challenge, and we did 2 phases for the challenge. First phase was ideation. We said, give us your best back of napkin thoughts. If you were to sit in industry on a shop floor and you had something like data, what would you build? What would be beneficial? And we had those announced back at MC Squared in Dallas this year. And then the second phase of the whole challenge is on applications. That's the building of the app itself. So what we have today, we have students, you're going to hear from them directly about what they did to build their app and the benefit of that app to the production and manufacturing environments. So what I would like to do right now is I want to bring up to the stage the OSD director of the Manufacturing Innovation Institutes and one of the key primary funders and sponsors of this challenge, Ms. Tracy Frost.
Thank you. Thank you for having us. The Department of Defense partnered with U.S. Army Benet Labs, NCDMM, Mtconnect Institute, and AMT to support this student challenge. I'm so excited to see the hard work that was put into these projects and to see the results. Developing applications which create intelligence from manufacturing data, not an easy thing to do. Initiatives like these are very important to the Department of Defense. They introduce advanced manufacturing to the next generation of scientists and engineers, which ensures that we have a continuous pipeline of talent entering the advanced manufacturing field. These challenges also problem solve real problems faced by the manufacturing community today. That's impressive for students. My sincere thanks to the students that worked so hard on these projects, and congratulations. No matter where these awards fall, you and the manufacturing community have already won. Good luck.
All right. Thank you, Tracy. Appreciate it. Okay. So now we get an opportunity to hear from the students themselves. So at first up, we're going to bring, whoops, there we go, Miss Catherine Lovell from Rensselaer Polytechnic Institute, RPI. Catherine, come on up.
Okay, so hi, I'm Catherine, and I was the Mtconnect engineer for nc.js, which is a JavaScript application developed to integrate with the Step machine, which is a CAD software that is made for creating a very modular, very overhead view of the computer-aided machining process. And after you create the process in the desktop tool, you can parse it down into G-codes. And from those G-codes, you can then run it on a machine, and then there's Mtconnect. And the Mtconnect, I then take and put it into nc.js, which is a web-based application that can render the machining process in real time using the Mtconnect data that is broadcast from the machine. This can be viewed from anywhere in the world as long as you have a server and you have people that can log into that server. Then if you have a machine in Japan, you can view what that machine is doing in real time in New York City. We also have a number of other things that are useful in our application. You can follow the machining process exactly. We have working steps. We can see what tools are used. We have volume removal in real time, and as well as a tolerance suite where you can see where the data is deviating from the intended machining process. This, along with the Mtconnect, makes it very easy to detect faulting in the machine early on, so you don't waste time creating a faulty part. That is the gist of our application.
Fantastic. Great.
Yeah.
Thanks, Catherine. Appreciate it. All right. Next up is Sharab Kumar Singh from NC State University. Sharab, come on up. Yep.
Hello, everyone. I'm Shaurabh. I'm from NC State University. I'm doing my master's in industrial engineering. So let me give you a brief overview of what my project is, how it works. So the project is titled Real-Time Digital Verification of Product Manufacturing Data. Now, this has three key aspects to it. The first one is building an Mtconnect adapter for a Haas legacy VF2 machine. Now, this Mtconnect adapter is compatible with 16 different models of Haas. The adapter includes an Intel NUC, which acts as the brain, and is connected to the CNC through an RS-232 serial connection. Now, the agent XML output from the adapter is received by a central system which streams in the data to a PostgreSQL database. Now, it is very important to know that we need to have an infrastructure to scalably store the product manufacturing data. It is a high volume time series data. And this is the second key aspect. And thereafter, this database also invites a third-party ecosystem of apps to be built on top of it, which is the third key aspect. Now, with the real-time series data, as well as the product manufacturing data that is being stored in the database, we can build n number of different apps. For example, we have demonstrated two here. The first one is digital verification of product manufacturing data, where we are extracting the coordinate data from the data set and superimposing it over the CAD file and plotting it in an error map. So here we could actually see the deviation of the data points from the intended surface, and thereafter perhaps could point out to the quality control team, say, that we could list out which parameters need attention, which would be a great help. The second app is real-time data visualization and monitoring. Here, parameters like coolant level, spindle speed, spindle load, or even the tool path can be visualized. And at the back is a monitoring system which is deployed, which sends a warning email whenever certain parameters like coolant level fall below the threshold value. So finally, the hardware part of our solution was $200, and the installation of the Mtconnect adapter is fairly easy, and this could be a great commercial solution as well. And at last, thanks to Mtconnect and IMTS for this wonderful opportunity. Thank you.
All right, thanks, Shar. Appreciate it. Thank you. Okay, up next, Ethan Westcote from Georgia Tech. Ethan, come on, take the stage.
Hello, everyone. I'm Ethan. I'm from Georgia Tech. Hope you all are having a great time. So jumping right in, so what I did was I created a dashboard in Excel using Mtconnect. And so there's three main aspects to it. What it's meant to do is to return the current status you have of what's going on your machine. It's meant to log then the data over the period of a shift. And then it's also meant to update with an alert system too. And so running into that a bit, the alert system is just based off of like your threshold set by an operator that is using the machine at a time. It's also based on your e-stop status, so whether it's been triggered or not. Going into the current status, it's shows, it's based off of the execution status, what's been going on your machine, and shows the recent utilization, how much time you have left on a part also. And so Excel was, the reason we used it is because it's an off-the-shelf product. Most businesses have it, and it's easy to come by too. Knowing VBA also helped, contributed to that also. And so this is the Mtconnect dashboard behind me, and thank you.
All right, thanks, Ethan. Appreciate it. All right, for the last of the presentation, Samson Joe from Rice University. Come on up, Samson.
Hello, everyone. This is Samson from Rice University, and thank you for having me here.
Absolutely.
Today, I would like to show you Mtlogger. So before Mtconnect, every machine tools that you have, it's a mystery box. Oftentimes, it's really hard to get the data from it, and you don't understand the data in it. But with Mtconnect, not only can we get the data, we also get a semantic of the data. That means we understand what the data is. And Mtlogger is a real-time data visualization application. You just need to host it in your factory and plug in the machine that is utilizing Mtconnect protocol. And after that, you can just select the machine that you want to visualize and the data point you want to visualize. On my poster, you can see there are some data visualization on a CNC machining tool and a little toy engine that I made up. So yeah, this is Mtlogger, a real-time data visualization application that lets you visualize your data without doing any programming. Thank you.
Thanks, Samson. Appreciate it. All right, guys. Nice round of applause for everybody that's presented up here. Before we get into the ranking order, which we're going to do in a moment, I want you to look at the poster boards here. So we have 4. After we're done, the students for a few minutes are going to stand by their posters. If you have questions about what they do, how it transcends into industrial, what's the next step, what would you do better next, all these other good things, ask them by their posters. And we're going to spend some time with the students down here as we do that. And one other thing, you guys know that life doesn't happen in a vacuum. These are full-time students that did this challenge with a full load of coursework in their own universities with their own milestone projects, capstones, you name it. And they still found time to figure this out, if you will. They took the time. So I think just that alone is almost goodness for having you guys here, because this is not an easy thing just to go do. Forget what you actually had to build and with all your coursework. So with that, I would like to recognize on the finalist side from, let's see here. Oh, we don't have it on there. Jansen Joe. Come on up as a finalist. I thought we had the university there. Good to go. Thank you, man. Appreciate it. There we go. Look at the camera. I'd appreciate it. Thanks again. Congratulations. All right, and we're going to our third place. Shaurabh Singh, come on up from NC State. Thank you, buddy. All right. All right, good job. Congratulations. We have our second place, Catherine Lavelle. Come on up from RPI. Thank you, ma'am. Good job. There we are. All right, thanks again. And first place, by elimination here, Mr. Ethan Westcote from Georgia Tech. Come on up, Ethan. Congratulations. Congratulations. All righty. Hey, guys, have a seat. Thanks again, everybody. Listen, certificates are one thing, acknowledgments are another. What really helps these students to hear what you have as a challenge, go and talk to them at these poster boards. We're going to do some more interviews on IMTS TV later, so you'll get to hear a little bit more about what it took to develop these applications. But if you have some questions, take a couple minutes now, and the students, if you guys will all walk down by your poster board now, we'll call it a day for the presentation. Thanks again, and enjoy IMTS 2016, everybody.